Last time, we talked about quantum entanglement, and how the spooky action at a distance might not be so spooky if we understand particles as standing energy waves in ether. Today, let's apply that idea to real experiments, specifically, the ones involving entangled photons and polarization filters. So here's what the experiment looks like. A pair of entangled photons is generated, and then separated. One goes to the left, and the other to the right. Each photon passes through a polarization filter. Now here's where things get interesting. According to mainstream quantum theory, when one photon's polarization is measured, its wave function collapses, and instantly determines the state of the other photon. That's what gives rise to the idea of instantaneous influence. But how does that fit into the ether wave model? Here's how I explain it. Each photon is not a point, but a wave structure spread out in space. So when one of them passes through a polarizer, its wave function collapses due to the interaction, and the information about that collapse travels to the other photon's wave. This causes the other photon's wave to adjust, aligning its polarization in the same direction. But here's the key. This information exchange is not instantaneous. It still requires time, because the interaction travels as a wave, not as a magic signal. Now, what happens if both photons pass through their respective polarizers at the exact same time? In that case, there's no time for the collapse information from one side to affect the other. The entanglement is effectively broken, or more precisely, the wave coherence is lost. This is also known as decoherence. However, the delayed influence of one photon's collapse can still affect the wave environment on the other side. That, in turn, can subtly influence how future photons interact. And here's the final point. These experiments don't just analyze single photon pairs. They rely on large-scale statistical results from many entangled photons. So what we see is a pattern, a statistical correlation between the measurements on both sides. That pattern suggests, yes, there is influence between the entangled photons, but it's not instantaneous. It's a wave-based interaction through the Aether that respects locality, causality, and still produces the same observable effects. In short, what looks like instant spooky action may just be a delayed, wave-mediated interaction. And that's how ether theory explains the results, without breaking the speed of light or locality.